Hello, this is a tutorial on the usage library editor of the urban energy platform SImStadt, which is developed in the Hochschule für Technik Stuttgart. For more information on the SImStadt platform, you can watch the SImStadt tutorial made by Romain Nouvel on the 2nd of June 2015. The usage library editor allows to create and edit libraries of usage types which are used in the usage preprocessor workflow step of the SImStadt platform in order to provide default usage parameter to buildings whose usage data is not known. First, I will import a standard library in order to show you how it looks like. Once the library is loaded, it appears in the left part of the GUI, as well as all its usage types. We can also see the usage variants by clicking on the items next to the usage types. The right part of the GUI can contain two different views. Now, this is the library view, which shows parameters on the library, its name, source, and description. And in the lower part, there is a mapping table. In the SImStadt application, the building don't have a zone usage type explicitly. They have only a code which must be linked to a usage type. That's why a usage library needs such a mapping table to link usage code to the usage type. Most of the mapping only have one usage type, but some of them have two usage types. The library view also has a variant table, which appears if you click on the variants button. It shows all the variants of the usage types of the library. The other view is the category view, which appears in the right part of the GUI if you select a usage type or usage variant in the left part of the GUI. This usage category view shows the name, description, and variant of the selected variant or usage type. And in the lower part, there are the tabs containing the usage parameters. The first tab is the occupancy tab containing occupancy data. For example, the occupancy density, which can be given in person per square meter or square meter per person. There is also a profile panel to give the occupancy density as a time varying function and not only as a constant. Here there is no profile for occupancy density. The intern gains tab allows to add and edit intern gains. Here there is one intern gain, persons and home appliances. You can set the value and the fractions, and it is also possible to provide a profile for this intern gain instead of just giving the average value. In the space heating and space cooling tabs, you can give the heating set point temperature or cooling set point temperature and setback temperature. You can also give this temperature as a profile and not as a constant. Here you can see there is a profile. In the domestic hot water tabs, you can give the water average consumption as well as the preparation temperature. The average consumption can be given in 3 different units. And it can also be given as a profile instead of only a constant. It is the same in the electrical appliances tab. You can give the average consumption as a constant or as a profile. And in the ventilation tab, you can give the healthy air change rate in 2 different units. I will now create a new usage library. So once it is created, it appears in the left part of the GUI below the already existing libraries. I will modify the new usage type, which is already here. I will add an intern gain. So let's call it intern gain 1. I give some average value, and I will modify the fractions. The sum of the fraction must be 1. So if I modify one of the fractions, the others are modified so that the value always stays 1, 100% or 1. I will also add a profile So the profile is not exactly an average integer gain each time, but it's the evolution of the percentage of the average load given here. You can actually give 5 different profiles for 5 different type of days. Let's choose the weekday. The profile can be simply imported from a CSV file, and then it appears in this graph. A profile is only a series of values which must be separated by a constant time step. Then the time step can be easily deduced from the number of values of the profile, because there is only 24 hours in a day, so you need, by dividing by the number of values, you get the time step, and it is automatically calculated here. You can choose to plot a cumulated or an instantaneous profile. In the XML file, in the library file, only the instantaneous profile will be saved, and this instantaneous profile will be used in a SImStatt time simulation, which are not implemented yet. Now I will add a few end uses. To do this, I click on the Add button and I choose the one I want to add. Note that now the domestic hot water is added and activated. It will be saved in the library if I choose to save it, and the other here are not activated. The average water consumption can be given in 3 different units: the default unit, and the unit in which it will be saved in the library file is liter per person and per day. It is also possible to choose the kilowatt per person and per day, but then you have to give a cold water temperature, because to do the conversion you need to know how the water needs to be heated. And you can also choose the kilowatt per square meter per year. Then you need not only to provide a cold water temperature, but to provide a non-null occupancy density in the occupancy tab. For example, here there is no occupancy density, and if I try to give an average consumption in kilowatt per square meter and per year, it is not possible. Indeed, then it would be impossible to save the value in liter per person per day. So I give an occupancy density, and then it is possible to provide the correct value, the value you want. It is the same for the ventilation end use. You can choose between 3 units. The default unit is the volume per hour. You can also provide a cubic meter per hour and per square meter. For this you need to provide a ceiling height in order to convert later. And if you choose the cubic meter per hour and per person, you need to provide a non-zero occupancy density. Now I will add a variant to this usage type, simply by clicking on the Add Variant item of this menu. The variant has the same properties as its usage type, but I can modify them, and if I modify these values, then it appears in bold. In the variant table of the library, then we can see that the new variant appeared. In the left part, we can see some warning icons. They indicate that the library is not valid. That is, it cannot be used in the SImStatt application because some parameters are missing or not correct. For example, here in the new variant, there is no usage days per year attributed, no usage hours per day, and so on. You can see all this warning message by clicking on the Validate button of the library view here. Here the first message is that the new usage type is not mapped. It is impossible to save the library if one of the usage type is not mapped, so we are going to create a new mapping. Here I can give the value of the code, and then I can give the name of the usage type. It is also possible to give the name of the mapping type, for example ALKIS for ALKIS mapping. Then it is possible to protect the libraries by clicking on this protected checkbox. It will prevent further modification. For example, now I can't delete or add any mapping or any variant. And in the category view, all the text fields are disabled, and so it's not possible to modify it. At last, the library can be saved using the save item of the file menu. So this is the usage library editor of the SImStadt application. For more information on SImStadt, you can watch either the SImStadt tutorial or the physics library editor tutorial, which explains how this physics library editor works. It is almost the same as a usage library editor, but for physics libraries and physics building type.